Astronomers have long assumed they'd have to look far and wide and deep into our galaxy before they found a single Earth-like planet. But now it looks like there may be many, quite nearby, perhaps as close as 13 light-years, virtually in our own cosmic backyard. Working with data from NASA's Kepler mission, scientists at the Harvard-Smithsonian Center for Astrophysics have calculated that 6 in every 100 red dwarf stars should have at least one Earth-sized world orbiting in the so-called habitable zone, where liquid water can exist. Red dwarfs are the most common type of star. They are much cooler, 1,000 times dimmer, and generally only about 1/3 the size of our Sun. So if you look up at night, your unaided eye won't see a single one. For every star you can see, there are at least 3 red dwarfs which you can't. But the Kepler telescope and other research instruments easily can. It's almost as if the universe wants us to discover these worlds. Earth-sized planets are much larger, relative to the dwarfs they orbit, than they would be to Sun-like stars. So they produce a much stronger light curve, in other words a dip in brightness, for Kepler to more easily notice. And even better, because red dwarfs are cooler than our Sun, the Goldilocks zone, where temperatures are just right for life, is much closer into these stars. Which means 1 year on these speculative planets is much shorter than our year. Which means it takes Kepler much less time to see multiple passes of these planets and thus confirm their existence. But perhaps most intriguing, red dwarfs have lifespans much longer than our Sun. So scientists speculate that we might come across life on such planets around red dwarfs that is much older than life as we know it on Earth. It's not a clone of Earth. But for the first time, planet hunters think they have evidence of a planet about Earth size that could have liquid water in orbit around another star. Kepler 186f, the outermost world of a 5-planet system, orbits about 3 times closer to its star than Earth is to the Sun. But that star, Kepler 186, is an M dwarf. It's much cooler than our bright Sun. So, scientists of the SETI Institute at NASA Ames Research Center are confident the new world is in the so-called habitable zone of that star. M dwarfs live very long lives, plenty of time for possible life forms to develop and evolve. M dwarfs also tend to flare more than our Sun, but Kepler 186f is thought to be at a safe distance, and the enhanced radiation might possibly speed the mutation rate of organisms, driving nature's evolutionary tinkering there. This planet, discovered using the transit method by the highly successful Kepler mission, is only about 10% larger in diameter than our planet. So it's thought to be a dense and rocky world, like Venus, Earth, and Mars in our own solar system, which hold atmospheres made of gases released by their own volcanoes and water collected from impacting comets. Planets larger than about 1.5 times Earth's diameter begin to draw atmospheres made of hydrogen and helium, like our Neptune and Uranus. And they keep on puffing up, like our Saturn and Jupiter, and even growing much, much larger into what scientists call super-Jupiters. Gas giants are not conducive to life on their surfaces, if they even have solid surfaces. No one knows at this point what the surface of Kepler 186 is really like. If there is water, it could be frozen, because the planet is pretty far out in the star's habitable zone. But being larger than Earth, it might hold a thicker atmosphere, which could keep the temperature up and the water liquid. As for the possibility of life on Kepler 186, that may have to wait for a future generation of telescopes. The planet is about 490 light-years away. We'd likely need a powerful space-based instrument to detect oxygen, ozone, or methane in its atmosphere. Seeing those gases in abundance would likely be the products of biology, life as we know it. Of course, there is a small, but not unrealistic chance that intelligent life could have evolved there. And an even smaller, but still valid possibility that they are, or were, transmitting radio signals now detectable by our technology. Specifically, the SETI Institute's Allen Telescope Array, which has in fact begun making wide frequency range sweeps of that part of the sky.